Welcome to my YouTube channel. Today we are going to solve an example about fractional knapsack problem. Imagine you run a store and you want to place the most profitable items on the small table at the entrance so customers see them first and they can buy them directly. But the table has a weight limit of 30 kilograms. So, what combination of fruit should we put on the table to maximize total value? Given that we are allowed to place fractions of a fruit type. For example, we can put part of plum's crate. We have 4 types of fruits in the back room. So, apples are totally 7 kilograms and their total value is $70. Melons are 12 kilograms and their total values is $72. Figs are 7 kilograms and their total values is $56. Plums are 15 kilograms and their total value is $90. The table can hold only 30 kilograms, so we are allowed to take any fraction of each fruit type. For example, we can take 4 kilograms out of 15 kilograms of plums. So the goal is to maximize the total value placed on the table. As you might remember, in the 0 or 1 knapsack, items are indivisible. So you either take the whole item or you don't. So we needed a dynamic programming in that case. However, here items are divisible. That means that we can use a greedy strategy that is optimal. And this greedy strategy says that always pick the next kilogram from the fruit with the highest value per kilogram. And the greedy idea for this problem basically says that choose the highest density, which means that always, let's write it in different colors, always choose the highest density, which means that value per kilogram. In the algorithm, the first step was calculating the densities for each item. So we will do the same thing while we are solving the example. First, we will calculate each densities. We will sort them in descending order. Then we will try to fill our table. So first of all, we are going to calculate each densities for each item. So, calculate densities. Okay, for apples, it is, as you can see, $70 for 7 kilograms. So, $70 for 7 kilograms, which will give us $10 per kilogram. For figs, it is $56 and 7 kilograms again, which will give us $8 per kilogram. For melons, it is $72 for 12 kilogram, which will give us $6 per kilogram. And what else? Plums. For plums, it is $90 for 15 kilogram, which will give us again $6 per kilogram. Perfect. Now, as you can see, melons and plums share the same density values. So in this case, we can order them in either way. So it doesn't matter if we first write melons or plums. It doesn't change the final maximum value. So we can take melons first or plums first. It doesn't matter. Then in the second step, we will order them in descending order. Okay, as you can see, they are already sorted from the highest one to the lowest one, so we can directly write it is apple first, then figs, then we can say melons, but it doesn't matter, we could also say plums, and finally we can say it's plums. And in the third step, we will try to fill the table as long as the capacity is greater than 0. So, as you can see, in the first step, since the best density is apple, we will take apple. Take apple. We will take all apples, which is 7 kilograms. So, we can say capacity left is 23 kilogram. And the current total value is, what was the value of the apple? It's $70. Okay. In the second step, we will take figs. Let's see. It is also 7 kilograms. So since our capacity left is 23 right now, we can take the whole figs. So take all figs, which is 7 kilogram. So capacity left is 16 kilogram. And total value is going to be 126. Okay, now let's write third here. Now we will take melons. Take melons. Since the current capacity is 16 kilogram right now and melons have 12 kilogram, we can take all melons. Take all melons, which is 12 kilogram. So the capacity left is going to be 4 kilogram, and the total value let's see. Okay, it's 72, so it will be $198. Okay. Since we have still capacity, we can continue. Now we can look the plums. Let's see. As we can see, plums are 15 kilograms in total. So we can't take all plums. We need to get fraction of it. Since we only have 4 kilogram capacity left, we are going to take, let's first write it is plums. We are going to take 4 divided by 15 of plums. So At the end, the capacity is going to be 0 directly. And the added value four divided by 15 multiplied by 90. So it will be $24. And total value is going to be $222 in total. So at the end of the day, we can say that we will take all apples all figs, all melons. However, we will only take 4 divided by 15 plums. So if we put them on the table, it will give us the maximum profit that we can reach. So in this stored table example, fractional knapsack gives a fast, optimal way to maximize value when partial amounts are allowed. We solved by value per kilogram, filled the table in that order, and reached $222 at exactly 30 kilograms. In the next video, we will implement this in code and return both the maximum value and the fraction taken from each fruit. I hope you liked this video. If you have any question, please leave a comment. Thank you for watching. Have a nice day. See you in the next lecture.